Hello everyone. Let's talk about the solutions for these two questions. And the first one is given the PDF of x and y, thus and z and the random variable z equals x plus y. Let's find the PDF of f of z. And the first we want to calculate by direct calculation method. F of z equals f of x, fx of z convolved fy of z. And according to the property of unit step function, we know that this integral doesn't equal to 0 only when alpha is greater or equal to 1 and less than 2, and z minus alpha is greater or equal to 0 and less than 1. That's alpha is greater or equal to 1 minus, less than 2, and alpha is greater z minus 1 and less or equal to z. We can plot it on the graph. Let's look at this. And the shaded area means the valid region for alpha. So f of z, when d is greater or equal to 1 and less than 2, we can find x should from integral from 1 to z. So f of z equals integral from 1 to z delta alpha, that's z minus 1, and when z is greater or equal to 1 and less than 2. And when z is greater or equal to 2 less than 3, z should integral from alpha should integral from z minus 1 to 2, and so f z of z equals 3 minus z, and for other values it equals 0. So we can express it in one formula, that is like this. And second, we should calculate it use geometric method. That should be easy. First, we should find the domain of x and y. It's easy to find that x is from 1 to 2 and y is from 0 to 1. So we can, from this graph, we can directly discuss the different situation. First, for z is greater or equal to 1 and less than 2, capital F sub z of z equals probability of x plus y is less or equal to z. Now we can easily know that it's just like the area of this shaded area, say the shaded triangle. That's z minus 1 to the square plus over z minus 1 square over 2. We can find the PDF of z by derivative of capital F of z. That equals z minus 1. And when z is greater or equal to 2 and less than 3, the area of the region should be like this. The square minus the triangle. So it's 1 minus z minus z minus 2 square over 2. We can derive it to find fz of z equals 3 minus z. And for z is greater than 3, like this. So in this situation, the capital sub z of z equals 1, so the PDF of z equals 0. So we finally find the answer and compare it to the first one. They are the same.